morning, everyone. I'm from South Korea. Thank you for your all. So especially Dr. Karika is my big brother. He was in Korea at the time. I was a little boy and great student. But right now, I became the scientist. And I'm very thankful for you all and the president and for organizer, especially Dr. Sharma. Today, focuses more specifically on the anti-cancer property. But my background is some mass propagation and including the secondary metabolite. Some of them include the anti-cancer property and others. So please understand, even little bit the background is a little bit out of way for this conference, but all related. I think I should include my talk yesterday because my background is more related to secondary metabolite, but it's yesterday, today the conference topic will be related. So, okay, first of all, before I come into my original talk, I want to introduce something. This is Korea. Maybe you know about the geography. And I'm from South Korea. In the middle of South Korea, there is a region that's located in my institute. And maybe here, undergraduate or graduate students maybe know about K-pop. K-pop means Korean popular music. So, and also this is the alphabet. This is what we call Hangul. And this is the flower, Lord's flower. This is our nation's flower. So, and also, I want to move our institute. We call KION, Korean Institute of Oriental Medicine. Would you please move another slide, another folder? Not this, another. Yeah, our president of KION, he gave me English version of introducing our institute. This is the main building, and we have some facility lab for the animal and in vivo and in vitro system, and some research center too. I'm not going through all of this, but just to skip some of them. We have a 24 international and local institute in Daejeon, and 24 in local in the Daejeon. We call Daejeon Innopolis, like in USA, California, they have a Silicon Valley. And our institute here, this blue color is all government funded institute. In 1994, we established about 20 years. It was 20, almost 20 years. And last year, we have some celebration. And we have a mission here for the past life. And vision is here for top class traditional medicine and alternative medicine. And we have a ancient for a long time, maybe 1,000 years ago, we have an Old Testament. And then we try to improve, and this is true or not, scientifically. So we have some technology advance. So by now we're doing the standardization and advance for the proof. And this is all we are doing at KION, and this is the organization. So I'm here for global research center. And budget, and we are doing some picture. We have Cavalry too, and then a documentation, and some main research center, and handling, building, and research center too. If you guys have a chance to visit Korea and Daejeon, I can show this one too. Okay. Can you? And not just, I want to finish this introduction. Korea, we are little bit, we have clear four seasons: spring, summer, fall, and winter. And nowadays, as you know, the greenhouse effect, the temperature is going up. And from past to current, temperature still increasing one by one. And because of the atmosphere, the carbon dioxide is problem. And it is impact on the human. Maybe the sea level change and extreme weather and acid rain and a lot of things going on. And in the forest, impact too. Changing the temperature here, and some animals die, and plant also. So changing the distribution, the range, ecosystem is affected. How we can control? Maybe you can plant more and selectively choose some specific tree or plant, and you can develop the alternative things and try to reduce fossil fuel. That is maybe you can try. But in Korea, for example, we have a island, Jeju Island. It's very warm area here. And now, maybe 40 years later, 100 years later, the percentage and contribution will be changed. And sometimes it's good, sometimes it's not good. So for the alternative medicine or the current situation, we have to do and some controlling about this warm temperature. And we can, this is Chinese, this is Korean. This means now we have dangers because of the weather change. And also at that time, future and current, we have a chance. So in this time, even we have a problem, but I can say for future, we can do something for that. So this is maybe candidate in Korea we can do in one area. I'm working on this kind of plant, and maybe in India or south of India or Bangalore, maybe you have this similar plant going on. And another one temperature area there can be grow, and sometimes it's difficult to grow. I can take some tissue culture for propagation and then try to extraction of oral medicine from it. And printing, as you know, is very common in Korea too, and we do some scientific analysis, and this is action is possible. And long time ago, traditionally, we also use this strategy too, and nowadays too. And Chico Biloba also good medicine. Now I want to talk about the current project. And in our institute and our group, try to do development of basic technology for the domestic cultivation for the herbal medicine resources. And first of all, if we choose one of the plant top, the root rhizome we're going to use, and 1,000 years ago we have this kind of plant. I don't know the English name, this is scientific name. Usually we use the rhizome or root, not the leaf. And then we verify this is correct or not. We have a marker genetically. It's ATS or 18S ribosomal DNA. And then we move to good seed. This slide showing about seed technology base. So there are seeds. We have to do good selection. And sometimes we have the basic selection. But right there we have X-ray system. That means on seed they have an embryo. The embryo is a good or bad. We can screen and then move on the multiple diamond germination. PCR case we have a melting temperature from each small temperature to higher level, and we have a table. Inside the table, we have a water line, and then try to optimize what temperature is best for germination. For example, 15 degree to 30 degree. And then we do some statistical analysis here and seed germinate. Okay, so maybe 20 degree is good for this seed. And then we move on the field and then mass propagation in the greenhouse system like that. This is a seed technology base. And another one, in vitro tissue system. And this is our project plant. So we have more, but I just choose some of them. And this is the same thing. And then we checked genetically. And then they have some bud, and then root, stem, leaf, and try to find which one is the best for this propagation. And then we clean all tissue and some leaf and seed or bird and try to propagate rapidly and also optimization. And then which media is best. And then we compare others. And then optimization in the field and the soil. So this is based on the culture tissue. And last one was the seed base. So sexual propagation and asexual propagation, both systems we are doing. And I want to introduce some secondary metabolite, some of our plants. And as you know, what is secondary metabolite? But 2 days ago, I just stopped by Department of Biochemistry with Dr. Kariga in Bangalore University. At that time, I didn't have this activity. I just briefly making 20 minutes or 10 minutes talk about secondary metabolite and propagation. And I asked the people and students, what is the primary metabolite and what is the secondary metabolite? And some of them said they know something, but it's difficult to say at that time. But for me, it's my knowledge. The primary metabolite is just food for plant. We also eat chapati and rice every day, right? I did in the morning too. So this is for growth, for my energy, and for generating the energy. But secondary metabolite sometimes not necessary for plant, even meat. But human can move around. Something is going on, but I can against them. But in plant case, they are stable. They have to be in the certain area. And they have some stress from environment or somebody cut tissue. That they make the depending some system, defense mechanism. And they persist in some alkaloid, terpenoid, and many other metabolite. This is secondary metabolite. And this secondary metabolite we can use anti-cancer, anti-other property, and medicinal purpose. This is the secondary metabolite. And today, more I want to talk about the Scopolia paviflora. This is a traditional medicinal plant in Korea. Maybe in India, Datura or Atropa, maybe Bosia, this kind of similar family or genus is available. This tropan alkaloid, this is for the painkiller or pain remover. Long time ago in European country, they have his name is Cleopatra. She wants to make her eyes bigger, and using at that time extract. She using the extract on the eye, and temporarily she make a big eye. That means she wants to be the beautiful to somebody. So this kind of material I'm doing here is a proposed. And I can keep moving on other list of herbal medicine too, but I'm going to move back on the Scopolia again. And this is Orostachys japonica. This is one of the list I was, not wrong. And also, this is a tree, a topinoid, and then tree forest on this plant. And the mosquito cannot come to the forest. With the topinoid is the volatile compound, and then they against some insect. And Chico biloba is I did some of the research some time ago. And also same time I'm doing the biomass production. We can call multiple propagation. And this is good for the reducing. If you have alcohol like a whiskey and beer yesterday, and our Asian or traditionally we extract this leaf and stem bark with drinking with water, and then this is can reduce your alcohol. It's that of course. And we have a citrus. So in Jeju Island we have a lot of these things. This for food, fruit, and sometimes food for the minor food. Sometimes you can use the medical for too. And so sometimes the people confuse about GMO, but this is not GMO, not non-GMO, but this structure is also advanced technology. But sometimes, like the student or normal people thinking about, oh, this is a chemical use. But it's not. This media we can eat. This is the ABA and some of the nutrition. We can even eat them all. But people thinking, okay, there's some problem with genetically if you mass propagation after that. So we usually checking this control and then field of wild type, the plan between the mass propagation and then accumulation here, and then we have some line. Its pattern was the same. That means genetically it's very safe. So we don't have to worry about the genetic problem at the propagation. And this is also good method too. I did try to do some breeding with some genetic selection. And also nowadays vertical propagation is important. So routine cutting. But in the field, it's easy to do it. But if you're thinking about the in vitro system, this is in the grapevine, and this is in the beaker with the clean area. And rootstock and science is grafting, and then multiple propagation. And at the same time, we want to know maybe their rootstock and science have some interaction. So maybe some RNA transcript and then expression. So we want to know some kind of mechanism when we doing some grafting. So this one is going on, is not finished yet. And now I move to the Scopolia. Scopolia is the Scopolia cauliflower is the native plant in Korea, and seed propagation is possible, but it's in the field area, in the mountain, it's difficult to find the seed. And nowadays they have rhizome, and the learning rhizome can make a propagate from the roots. And this is the propagate. This basically Scopolia, scopolamine and hyoscyamine is 1 gram is 400 US dollar right now. And as we know, culture is benefit, and I'm doing culture Thai, and sometimes we need genetically agrobacterium too, but basically for the food or medicine, usually just normal propagation is better. So we still have GMO problem. And plant propagation, as I know, we have two things. One is seed propagation, the other one is asexual method is rooting and cutting and grafting. So we have many choice, and actually for this plant, I did a lichen culture. So it's organogenesis through the lichen. Lichen have many methods. And first objective was in vitro system optimization. And that means we try to reduce the time to propagate. That means we accelerate the level of propagation using lichen. And also, same time, germplasm conservation also important. And it was published the pencil report. And in the field, I cut lichen like that, and put in the beaker in vitro system. And sometimes they have many multiplication, and sometimes they have rooting. Especially trophon alkaloid, we can extract from the root, not the stem or other callus. And then making in vitro propagation and move the field and germplasm conservation too. So it's a two purpose. At that time, just 3 months from here to there is only 3 months. I need that. So that's why it's naturally we can make it more and more. But usually in the field, the lichen and or seed propagation, naturally they need 2 years. So compare with 2 years and 3 months, definitely this method was really good for the multiplication. And another thing was we needed trophon alkaloid, and this is a pathway. It has a key enzyme like PMT and H6H. So main trophon alkaloid product is histoamine and scopolamine. So we handle PMT and H6 in the cloning. And these two enzymes, using the agrobacterial system, we overexpression PMT and H6H and high content of trophon alkaloid. And PMT and H6 was working on this kind of things, and then we use the healthy system. And then Mokurukaji, I don't know the region exactly, but this is advanced root, and then with the agrobacterium, and they make a hairy root. And from the hairy root, they have a lot of trophon alkaloid, which can be extractable like this. And it was the vector. And also we chose some line, and then compare with the wild type and PMT and H6H for expression in RNA and protein level. And this is a line for that. And then also growth index is high, and the production of trophon alkaloid was really good too. But in secondary metabolite, it's always there a correlationship between growth and production of content. But in case we catch two levels, right? That means we increasing the growth index, that means mass propagation, and also same time increasing the content of secondary metabolite. And the other one is application. That means scale up. We usually do small flask, like 100 ml, less than that. We'll move to 2 liter, 20 liter, and 2 ton, and then industrial level. And this is very important. You will have some herbal medicine, roots or whatever you have mass, and then you want to use for the medicinal purpose. And at that time, you can make in your lab system, but how can you make a drug for anti-cancer or anti-obesity or other medicine? Of course, we need some system like that. So first of all, optimization condition and move to another, how we can increase the content of secondary metabolite. And they have a lot of ways to get away. This is one of the example. Try to find which medium is best and growth part and content of trophon alkaloid part. Always thinking about the mass and then time in the production of content too. And another way we can increase and growth regulator, some auxin and cytokinin, and some sucrose, a percentage 1 to 9, and fructose and glucose. This will be good food source and definitely be high. And this is a two-stage culture in the growth production. And then here we thinking about some growth ingestion. Here the best one is here. That this figure telling us we have to think about growth, we have to think about content. So what we did the relationship about content and growth. And then we thinking about this here, two-stage culture will be good. And then we can catch, we will be available on the content part and growth part. And the other one, we have a elicitor. Elicitor means a non-biological. So we have a biotic and abiotic. So this is some chemical. We know the salicylic acid and methyljasmonic acid can be controlled about some stress system. Of course, fungal elicitor, this is alive. There's some pathogen have some attack to the plant. So this is biological. We test non-biological and biological elicitor for increasing the content of the trophon alkaloid. Methyljasmonic and salicylic acid elicitor non-biologically we increasing the 6 times, and this is a checking of protein expression too. They have a certain amount of salicylic acid and MJ, and time-based we check. So they have a certain point they have increasing the protein enzyme. And biologically, we choose some bacteria and some fungi and also phosphorus. But the problem was they make a contamination when we co-culture with a hairy root. But it's a kind of scientifically, we try to know the mechanism of our elicitor. But for industrial level, the biological elicitor was not good. And this is a small scale of a bubble system. In small scale bioreactor, we create our own cell. And this is a comparison. And plastic mass is like that after 4 weeks. The bioreactor, like this 2 liter, is much bigger. So this is a small scale. And then we make this trophon alkaloid for Scopolia palliflora. Not only this, if you have a very good material in India or Bangalore, and then you need for the herbal medicine, at that time you need a lot of mass product, otherwise you cannot use at all. But if you try to do this kind of system apply to your plant, maybe you can extract a lot of secondary metabolite. And I want to talk about a little bit, but I am still a young scientist, but it's very careful in front of a very nice professor, and they know much more than me. But I want to suggest some of the things if I can do. When I was a PhD student in USA, they are doing a lot of GMO things, genetically modified trees. And my background was forestry and some horticulture, so definitely interested in tree things. And of course, I agree with some research about growing gene can be improve our biomass for particular purpose. But we can talk about this case study, for example, herbicide this tree, this is a fact, wild type, they are going to die, but they are okay for the pathogen. And also this is another thing, if you, right now, especially one area, many unknown or known insect or pathogen can be attached to the tree or leaf of a plant. GMO, I'm not telling you GMO is good or not, but we have to think about ecosystem and use pesticides and biodiversity. But still, we have to do this kind of thing or not. I'm still thinking about it. Maybe I'm giving you some idea or some chance to think about this kind of biotech is okay or not. I still give you some question. And another thing is I like breathing and durability. In the plant, when God gave us plant, and plant have a lot of ability for human. And for example, this tree, we call Hamsulam, maybe you similar genus or species you guys have. This plant, I saw this one in front of the building, Bangalore building, but I'm not sure this is the same or not. So we use this one long time ago, natural paint pigment extracted for decay resistant coating. And we have a lot of benefit from the purple plant for medical purpose or industrial application. And this is another thing, oil. So Indian people like oil, and this is also another things. And we have this kind of oil for food, and also some dry, clear, blue, resistant decay. This is all kind of benefit. We have so many different kinds of plant available in the world, and especially India, Korea, Asia. And we have a lot of idea or technique. And now, for the pharmacologically, we can make some drug or currently, some vaccine, cytokine, antibody, and some advanced drug available. So even this technology, so we still need the basic plant material. So another one, this is a Danish tree. Sometimes people have allergy about this tree, but still the evolutional is good for decay and against for the pathogen and insect. So now I want to tell you the herbal medicine is important. And then using the tissue culture, that means we need the material more and more, mass propagation. Using this technique and then tissue culture, we can get a lot of material and then improve this technique for herbal medicine. And modern way, traditional way, and our Asian, they have all the text. And TKM is traditional Korean medicine, and TCM, traditional Chinese medicine.